Welcome back. We've been looking at rational exponents and nth roots. We're going to keep talking about nth roots, and we're going to be looking at domain and range as it applies to nth roots. So here I have an example of an nth root. B is equal to the nth root of A. So n is my index, A is my radicand, and B is the result of this radical. Domain is going to be asking the question, what values can go in? And range is asking what values can go out or can come out of my function. When I look at a table of values here, this is flipping the question. This is saying b raised to some number. So 2 and -2 would be like my values of b or my output. I'm flipping this question around and asking what's going to happen. So if I have a positive number and I raise it to any number, I'm going to end up getting a positive number. If I have a negative number and I raise it to a positive or to a number here, if I raise it to an odd number, I end up getting negative numbers, and if I raise it to an even number, I end up getting positive numbers. -2 multiplied by itself an odd number of times is going to give me a negative number. -2 cubed is -2 times -2 times -2, so it's going to be -8. We basically flip back and forth between positive and negative. How does that affect this? So what ends up happening, what we end up finding, is if I look at even degrees, I can't put a negative number into an even degree. So if I look at something like the fourth root of -16, this is saying what raised to the fourth is equal to -16. So I am saying I need some number multiplied 4 times by itself, 4 times, to get a negative number. When we looked at this with the square root of -4, we had to come up with a new number system called of imaginary numbers. But there's no real number. When raised to the 4th power or multiplied by itself 4 times, I'll get a negative number. This is true of any number multiplied by itself an even number of times. So if this degree is even, I can't have a negative number under the radicand. Under the radical. So the radicand must be positive or 0. Because of principal roots, my root must be positive or 0. So the domain is that we have to always have a positive number, and the range is that this value is always going to be positive. That's what we ensured with our principal roots. If this exponent is odd, if I have an odd exponent like the 5th power, this is saying what raised to the 5th is 32. So that's going to be 2 times 2 times 2 times 2 times 2 is 32, or 2 to the 5th is 32. So this is just +2. I don't have to worry about having, I'm welcome to have a negative number, because if you think about an alternative situation, the 5th root of -32 would just be -2 times -2 times -2 times -2 times -2. Right? -2 to the 5th is -32, so that's okay. So if my index is odd, I can put any number I want, -infinity to +infinity, under the radical. So the radicand can be all real numbers. What we saw is also that the radical is going to end up having the same sign as what's underneath it. The radicand and the radical evaluated will have the same sign. So all real numbers for the domain and range. So domain is not an issue I need to worry about if I have an odd power or if I have an odd index. Let's look at a couple examples of this. In these examples, I want to just state domain restrictions. So we're going to focus on the idea of domain restrictions right now. The square root of x plus 3. So my index is 2, that's even, which means my radicand, x plus 3, must be greater than or equal to 0. X plus 3 cannot be negative, or I won't have a true statement. I'll have something in a different number set. So x must be greater than or equal to -3. If I write this in interval notation, it looks like this. So x is greater than or equal to -3, or hard bracket -3 to positive infinity. Cube root of 2x minus 1. All right, so n is equal to 3. I have an odd index, so my domain is going to be all real numbers. So 2x minus 1 can be all real numbers. So really what this ends up being, or negative infinity is less than 2x minus 1 is less than positive infinity, or we just have all real numbers from negative infinity to positive infinity for x. So x can take on any value. It's perfectly fine. The fourth root of 3 minus 2x, our index here is 4. That's an even number. So the radicand must be positive. 3 minus 2x is greater than or equal to 0. 3 is greater than or equal to 2x. 3 halves is greater than or equal to x. Or x is less than or equal to 3 halves, negative infinity to 3 halves inclusive. That's how you're going to find domain restrictions. So if we have an even index, what's underneath the radical or the radicand must be positive. That's going to be key. So the domain is really what we want to focus on right now. It's going to come in handy when we're solving equations involving nth roots and rational exponents.